Hi everyone. Once again, apologies for my voice. In this tutorial, we're going to be looking at estimating the population proportion from the sample proportion. In the first instance, we're going to look at point and interval estimates. The sample proportion p hat can be used to estimate the population proportion. Because this is one value only and it's being used to estimate the population proportion, it is called a point estimate. As it is only one value from one sample, it is not very reliable and is therefore rarely used. Instead, it is much more reliable to use an interval within which the population proportion is confidently believed to be within. This interval is known as a confidence interval and is interpreted as an interval estimate. Let's look at confidence intervals. As you know, the most common confidence interval used to estimate the population proportion P is the 95% confidence interval. As you can see here is the formula for the 95% confidence interval for P when it comes to statistics and estimation. You can see that the interval ranges from this minimum value here to this maximum value here. And if you look at it carefully, it says P hat minus 1.96 times the square root of P hat times 1 minus P hat divided by n. In actual fact, it is very close to what we have learnt previously. Usually, the 95% confidence interval is the mean minus 2 standard deviations from the mean, or the mean plus 2 standard deviations from the mean. This is very close to 2 standard deviations. It is the same formula, except it is 1.96 standard deviations from the mean. However, instead of the mean here, we have got the sample proportion. Let's look at this example. Find an approximate 95% confidence interval for the proportion P of primary school children in Australia who regularly use social media. If we select a random sample of 20 children and find the sample proportion P hat to be 0.7. So in this example, the sample size is 20 and the sample proportion is 0.7. We first of all need to find the standard deviation. So we need to say P hat times 1 minus P hat over n, the sample size, and take the square root. In this case, it's 0.7 times 0.3 divided by 20, and when we take the square root of this value, we get 0.1025. So the 95% confidence interval for P is 0.7 minus 1.96 times 0.1025. And the upper limit is 0.7 plus 1.96 times 0.1025. And this means that the 95% confidence interval has a lower limit of 0.499 and an upper limit of 0.901. This means that based on a sample size of 20 and a sample estimate of 0.7, an approximate 95% confidence interval for the population proportion P is 0.499 to 0.901. Interpreting the 95% confidence interval. In the previous example, we found that the 95% confidence interval for the population proportion was 0.499 to 0.901. This confidence interval is based on a sample size of 20 primary school students and a sample proportion of 0.7. The correct interpretation of the 95% confidence interval is that if you selected a large number of samples of primary school children, each sample being 20 children, 95% of these samples, for example, 19 samples out of every 20, would have the population parameter within this interval of 0.499 to 0.901. We can use the calculator to very easily calculate the 95% confidence interval. Let's look at this example. A survey found that 237 out of 500 undergraduate university students questioned intended to take a postgraduate course in the future. Find a 95% confidence interval for the proportion of undergraduates intending to take a postgraduate course. Now, if I didn't want to calculate the interval by hand and I wanted to use my calculator, I would go to a calculator page and then go to Menu, Statistics, Confidence Intervals, and 1 prop Z interval. I would enter the values X is 237 and N is 500. This is what it would look like. X is 237, N is 500, and the confidence level I want is 95%. The screen I would get would look like this. And the important things I would look at here is the confidence lower level and the confidence upper level. Here it's telling me that the lower limit of the confidence interval is 0.430233 and the upper limit of my confidence interval is 0.517767. This means that these two values are giving me the 95% confidence interval. Later on, we will look at this value here, the margin of error. On our calculator, 1 prop Z interval is option 5 on the menu. Let's just demonstrate this on our CAS calculator. The first thing I'm going to do is go to a calculator page, and then I'm going to go to Menu. I'm going to go to option 6, Statistics, and then I'm going to go to option 6 again, which is confidence intervals. When I go to confidence intervals, I then go to option 5, which is 1 prop Z interval, and I get this screen. Remember, our number of successes, X, is the number of people in the sample who answered yes to the question. So I've got 237, and N is the number of people in the sample, and that's 500. Then I go down to OK, hit enter, and here is my screen. So we can see that my lower limit of the interval is 0.43. My upper limit to the interval is 0.51. So this is my 95% confidence interval, 0.430233 to 0.517767. So now, based on this tutorial and on the examples that you've seen done here, I want you to work on exercise 17D on page 17 of your 715 of your textbook, and do questions 1 to 6. These questions are all about confidence intervals, and in particular the 95% confidence interval. Thanks for watching.